You?
Hey, I'm doing all right. How about yourself, Kelly?
Yeah, I'm okay. I'm okay. I'm a little nervous this morning, so I'm finding myself having to take a few deep breaths today. It's definitely a lot going on, not just at Honeycomb, but in the world around us. So,
Yeah, yeah. It is not wonderful to have people dying of a variety of things. It's not a great thing to sit with, but we have to soldier on.
yeah,
We have to soldier on.
we do, and we do, and I really appreciate having this to focus on today. Everybody, it's just a minute after the hour. I'm going to start every piece of this in just a couple of minutes as we're letting people sign on. In the meantime, let me just do a little bit of housekeeping. Oh, I see people in the chat. This is so great. Hi, everybody. Of course, we have the chat panel going. Coco says hello, hi to all of you as well. Coco, you want to? She's mad. She doesn't want to be on camera this morning. But I do want to let you all know that we do have closed captions or open captions. I'm learning. We have captions available during this show. So you can either hit the button there at the bottom of your screen, or Bethany's going to paste a link if you'd rather follow along in your browser. Hi, everybody. Oh, this is fun. Yeah, please say hello. Say hello in the chat. Liz is here with me today to talk about the tarot of telemetry, helping your future self. I want to let you know that you can ask questions anytime. Just use the Q&A section in the Zoom webinar. If we don't cover your answer, we will have a Q&A at the end, and we'll get to as many as we can. If you see a question come up and you are excited about it, please upvote it. We'll do our best to cover as much as we can in this short period of time. What else is important? Closed captions exist. Oh, let's just say the thing that doesn't need to be said, but let's just explicitly get it out of there, out of here anyway. Just a brief code of conduct, since we have a lot of people in the room. We here at Honeycomb assume good intentions, so we're going to bring it today to raw and real. Please, as you talk in the chat, as you talk with each other, assume good intentions and no shaming language. Let's just make this a place where we all want to be. I think that's about it. You can ask questions, captions, little code of conduct. Liz Fong Jones.
Hello,
When
folks.
Hi. um, Honeycomb. When Honeycomb built out the SLO feature that we have, there were many considerations regarding which kinds of telemetry to start with that would be most helpful to make the best product for our customers, or the best feature for our customers. Can you please share our story? Share your story about this.
Yeah, I would certainly love to. So I'm going to share my screen, so hopefully everyone can see that. Kelly, if you could turn off your video so that it pins my screen in my picture, that would be helpful.
Sounds good.
Excellent. So, we built out this service level objective feature. We started this process about a year ago, a little over a year ago, and we launched it in January of this year. And for those people who don't know what a service level objective is, a service level objective is a way to measure the performance of your service over a longer period of time so that you understand what experience your customers are having. So when we built this initially for ourselves as well as for some of our customers. And this is what it looks like inside of the Honeycomb product. You'll notice that it says, hey, this is how you've spent your error budget over the past couple of months. This is what your reliability level in aggregate has been over the past couple of months. And here's what's happened in the past 24 hours. So there's kind of some of the key elements that we wanted to make sure that people had. But there are challenges associated with collecting this much data over a period of, 60 days. How do we query it? How do we make it accessible to you? How do we make it fast enough? So I want to show you as well what another SLO might look like that is kind of a little bit more actionable, that says like, hey, we had a big outage that burned like a bunch of error budget about a week and a half ago, right? And that we needed to debug that during the immediate incident. So when we were designing this, we needed to make sure that we understood what the performance characteristics of it were. So we evaluate your service level objectives once every minute, and we needed to be able to understand, like, how long is it taking to evaluate service level objectives? Is it too fast? Is it fast enough? Is it too slow? And kind of where are we spending our time in this process? So one way to approach this is certainly to create trace spans. So traces are kind of one of the core units of instrumentation inside of Honeycomb. So what we did was we decided we were going to extend the existing service that processes triggers, And instead of it only processing triggers, we wanted it both to process service level objectives as well as the existing triggers. So the trigger workflow that already existed kind of had this notion of we'll evaluate a bunch of different triggers, and then after all of them are evaluated, we'll go ahead and send notifications and return results. So we wanted to duplicate that pattern with service level objectives. So when we were creating this feature, we realized that we needed to change the cron job that gets invoked once per minute. And instead of, just evaluating triggers, we needed to also, in addition to evaluating triggers, we also needed to evaluate the SLOs. So this is a span that defines, hey, we want to keep track of how long does it take to evaluate all the SLOs, but that's not very helpful if one SLO is particularly slow. So for each individual SLO, we needed to create a specific span relative to evaluating that individual SLO. And we also needed specific bits of instrumentation around which SLO is it, which data set is it, and kind of instrumenting all the way down to the database that we understand, like, is it failing in our application code, is it slow in our application code, or is it slow inside of the database? So for instance, when we issue a call out to the database, we want to explicitly wrap that in a database span, as well as having kind of all these little tidbits of metadata. Which team is it? Which data set? Which SLO ID? And you can see over here that indeed, when I look at this one SLO here, we can see those additional pieces of metadata that I sprinkled in. So you can see the SLO ID, the team ID, how long it took, and you can also see things like which host did it run on, and other varying properties. And if you drill in even further, you can kind of see the individual database calls here. So this, for instance, is a get context database call that's issuing a select statement, and you can see it's very, very fast. But where we spend the majority of the time happens to be actually evaluating the SLO. So that corresponds in this code here to the code that actually looks at evaluating an SLO. So let's look at that. So this is where the code to generate the span is, where we are asked to evaluate an SLO. We create a new span, and we set, again, the attributes such as which SLO is it, but also we want to know, is there a correlation between the number of days over which we're measuring the SLO and how long it takes to evaluate. So we wanted to add that as a integer property. And we also wanted to carry through the dataset ID and so forth. And then after that, you can see that we go and do a variety of different things, such as fetching the counts from the database. And of course, when we fetch the counts from the database, as well as from our query backend, we need to make sure that it indeed is doing what we expect. So we need to have a span for fetch SLO counts. And then we need to have spans for things like, hey, how much time did we have that managed to hit the cache, and how much time we had to fetch anew. So again, we can go and look at this trace here, and we can see that, fetch the counts. We can see that the overall SLO window is 720 hours, or 30 days. And you can see that of that, the amount of time that we were able to fill out of the cache should be right here. So we should be able to see, actually let me search here, it'll be easier. Yeah, there we go. So validate cache is set to true. Fetch counts from retriever. How much did we fetch out of the cache? What is this property called here? This is kind of part of the fun, is that when you work with honeycomb instrumentation, or instrumentation in general, there's this lovely opportunity to go back and forth between your code in the trace and see where the two things line up with each other. For instance, I think that I can see here query hours. If I search for query hours, it should pop up inside of the trace span. Or maybe it doesn't. Because I'm looking at the wrong trace. Query hours. So yeah, we can see right here that it's telling me I had to do a manual query for 1/6 of an hour of data, but that the rest of it was filled out of the cache automatically. So this is the fetching out of the cache, and this is the live request. And you can see, indeed, that the cache is pretty fast, right? That the MySQL cache that we're using takes 50 milliseconds to evaluate, and that the storing back to the cache takes relatively little time, but that we spend 1.2 seconds actually asking our query engine for that data. So, yes, it does take time, but we want to make sure that we give you accurate results. And because we link all of the traces together, I can go ahead and look and see how long did this individual request take to execute, right? Like where did we spend that time in the, 1 second, or in the in this case the 300 milliseconds here? How long did it take, and where did we spend the time? So we can see here, for instance, that we actually were just blocking for 188 milliseconds because there are too many other queries executing in parallel. And then the actual request to carry out the search for how many requests succeeded and failed, or SLI, over that 16-minute window, or over that 10-minute window, we can see that took only 40 milliseconds to evaluate, and that most of that execution, in fact, all of it happened locally, and that we were just spending that time kind of coalescing the results together. So that's kind of some of the considerations that we had when we were thinking about implementing the SLO feature. How do we know that it's fast? How do we know that it's executing correctly? And when there are slowdowns, what's going on, right? Like, how can we debug whether it's slow? And indeed, one of the things that we found was slow before we added the cache was that we were querying every single minute for 30 days of data, and that was massively hitting AWS Lambda every single minute, and it actually generated a $10,000 AWS Lambda bill. Whoops, in addition to being really slow. But we had the correct amount of instrumentation to know that it was going to be very slow after we'd already made the mistake, and therefore we were able to correct it by adding the cache, and we were able to verify that the cache was working correctly.
Liz, if I can just ask a question real quick, pardon. I just want to imagine what I hear you talking about sounds really, really important right now. Like the idea of, okay, everybody, we wanted to build this feature. We're sitting in a room. These questions that you're talking about, the query questions you want to ask, making sure you have this is the key element, I think, for you talking about Honeycomb sitting in a room, the team sitting in a room, asking what questions do we need to make this successful? Are those the key questions to know what custom instrumentation you're going to need?
Yes, exactly, right? Like, you need to know, we can automatically measure things like duration, right? That's kind of the easy thing as far as Honeycomb is concerned. You just have to add that kind of beeline.start span call, right? But I think the more interesting questions are, what are the custom properties, right? Like, what are the things that I need to know beyond just what's the name of the span and how long did it take? But, like, who is it, right? Like, you kind of have to ask the who, what, when, where, how, why, right? Those are the kinds of things that you have to ask in order to really get all of the instrumentation that you need. You need to kind of break up your span so it's not just the top level RPC, but you have to say, what steps did I take along the way so that you know what you can attribute the slowness to if one of the steps gets slow.
Okay, thank you. Thank you for explaining that.
Yeah, of course. But I think kind of getting to Kelly's other point, right, like all of this stuff is useless unless people are actually using it. So one of the things that we really love to do is we really love to do things like understand who is creating SLOs. Are they having trouble creating the SLOs, right? Those are all super interesting things to explore. So I'm going to go over here and show you a little bit about the user events that we created for the SLO feature. So if this GitHub search works correctly, hopefully this does what I expect it to. There we go. So you can see that we've created not just server-side instrumentation, but we've also created user events around SLO creation. So that user events are a thing that we developed inside of Honeycomb that look at what people are doing inside of the browser. For instance, we can see, I can go and look to understand what is the actual number of customers who are performing the operation to look at their service level objectives. So let's have a look at that. So we want to run a count where name is, let's see, so SLO, the SLO heat map. So for instance, I can find out how many people changed the, let's look at 14 days of data. This will work. Let's try name starts with by name. Oh, I see the problem. It's warning me that the name of the field is actually not name, that the name of the field instead is action. Let's just have a look at, I just want to have a look at a little bit of data, and we can figure out what the field is actually called. This is a data set that my colleague Danielle works with more than I do, so therefore it's something that I'm less personally familiar with. But it's always great to explore. So what is this thing called? This thing is called no, that's not what I want. It's data mode.
But you can just sort through the raw data right there. That's so accessible.
Yeah, right. Like if I'm not sure what something does, I can always just look directly at it. So let's look at one sample event. What is this called? Oh, it's called type. That's what it's called. Okay. Type starts with SLO group by type. Knew that was going to bite me at some point. There we go. So now we can see that there were 189 people over the past 2 weeks who clicked the button to edit or create a service level objective. But we can see that 28 people clicked the button to create or edit a burn alert, which lets you know when you're going to run out of error budget. And I can go through and look specifically at the examples of where someone cancels editing an SLO, because I want to look at those specific sessions. So let's look at one of those sessions, and we can try to understand what happened. So the person did a bubble up over some data, and then they clicked the button to edit the SLO, and then they clicked something in the nav bar, and then they canceled their request to edit the SLO. Right, so this is kind of cool because it lets me understand what are people actually doing with their data, and are people actually using this feature that we developed in Honeycomb. And all of that is handled through this library that we have, where we want to measure the actions that people take in our UI as well as measuring the backend. So those are kind of two sides of the coin of how we think about instrumentation, right? How do you understand both, where are we spending the time in the back end, where's the latency coming from, but also, right, like, are people actually benefiting from the feature that we're developing? So that's really the demo that I had in mind to discuss today, is to show you a little bit about our thought process when we develop a feature for Honeycomb.
Liz, that's fantastic. I really appreciate it. I think that, here, I'm going to see if I can come back on here for a second. Video settings. I don't know how to bring myself back up, but that's just fine. I'm not going to worry about that right now. I think that one reason this really kind of stands out to me, it makes me think about how hard it is sometimes for people to just start something new. Mm-hmm. And when I'm in the middle of something that I do all the time, I forget how easy it can just be to kick off what are our goals with something. And mm-hmm. I love how deciding what telemetry is going to help down the road can really bring the team together about what's most important. Mm-hmm. And then I also learn, which is just well, now that we know what's most important, let's just kick the can and see where it goes. And then having the goal of understanding how your customers, how your users are actually using the SLO features, it means that we can try to get ahead of what's working, what's not working.
And where people are confused. Yeah. I think the other really awesome thing about this is that it's a practice that charity majors and I call observability-driven development, right? Like, as you're writing the code, you're thinking about how are we going to measure it rather than bolting it on after the fact.
That was going to be my next question. How does this tie into observability?
Yeah, so I think that we want to make sure we can debug things after they're running in production. We want to understand the how and the why, right? And that requires us to bake in observability from the very beginning in order to make sure that we have a shot at being able to answer those questions that we have as software engineers and as designers and as product managers.
Fantastic. That's great. I have no specific questions about after that. Does anybody attending have any questions for us today? I don't see anything come in. I haven't seen anything come in yet, so I want to encourage you not to be shy. Learning about how to read traces has been very important for me to understand how my teammates can actually see each individual detail about which part takes this amount of time, not just to improve our product for Honeycomb, but also to well, actually, that's exactly why. Um, it's what I want for all of our users. We have a question here. How do you determine what you need? I'm sorry, I don't understand this question. How do you determine what you need observability into? Oh, I think I understand. How do you decide where you need observability? Forgive me if I didn't get that right, but how do you decide
My
where you need
interpretation
observability?
is that the question is like, how do you figure out what kinds of questions you're going to ask, right? And the answer is you genuinely don't know, right? Like, but there definitely are dimensions that you might know are important, right? Like, I might want to know if the SLO feature is broken or slow for one specific user, right? So I'm definitely going to add that team ID. I'm definitely going to add that user ID who created it. I'm going to definitely add that dataset ID. In terms of what services you need observability into, right? I think the answer is you need observability into everything, right? Like you need observability into each end user facing service that you have. And as you encounter things that you can no longer explain with your existing telemetry, then you have to add new telemetry in, right? So if you discover that you cannot explain why the latency is slow because it's bottlenecked somewhere that you don't have visibility into, then you might want to add those database spans, right? And get observability into your database. But definitely the goal is to start as close to the user as you can, for instance, from your load balancer logs, and then drill all the way down. And that's kind of how the priority ordering is. Focus on the things closest to the customer first, and that's kind of how you get the highest impact.
Is that, I want to dig into that for a second, because when you say observability into everything, I can imagine if you don't really have, if you're not practicing observability in a way that helps you yet, honestly, that's kind of daunting. What's the key for you help when you talk to customers or prospects? How do you get people started? What's the
I,
one like?
yeah, I think that the reason that I love the idea of SLOs as a top level feature, right, is that it focuses you on what's the customer impact, can we measure the customer experience, and can we understand when there are degradations in the customer experience, and everything else flows downstream from that. So,
Okay, so
I
just make
definitely
that your
kept that in
goal.
mind when we were developing the SLO feature, but also the SLO feature itself aims to aid people in observability because it helps them prioritize where to measure.
Okay, so I just really want to repeat that back for the folks listening in. It's the idea of we talk about it for SLOs with us, but whatever you're building, where your customers are, where it's going to help your customers the most, that's where you want to start. So just get started. Okay. Also, let's see. Do you have a sense of how creating a span or adding a tap will add to the latency you're measuring?
Ah, so the answer is that it takes in general like microseconds of latency to just record the start and end of a span. And the way that we make it efficient is that you batch up the spans that you're going to send. So that's done in a completely separate thread rather than blocking inline. So the effect is generally negligible. It's going to be less than 1% of performance impact, unless you're in a situation where you're limited to a single core and you don't have another core available assigned to your microservice. So there are ways to mitigate it, but definitely that's kind of the performance impact. And if in the worst case you can sample, you can turn off tracing unless the die roll is 100, right? And that 100D 100, right? Like, and that kind of makes sure that you are getting the signals that you need while minimizing the telemetry impact in terms of the cost of the telemetry.
Okay, thank you. This question, what makes a good attribute name? Are there standard names that everyone uses, or is it more ad hoc?
I think as you saw me struggling with earlier with the kind of user events dataset, right? Like I think that the user event, the field called type was definitely confusing to me, right? So I think that the more you can standardize the way that you have your field set up, the easier it's going to be to understand, right? For instance, we definitely prefix everything that's generated from a application instrumentation with app. We definitely have prefixes for like global to define process level attributes. And then there are definitely things where like if it's an HTTP based service, definitely saying, hey, by the way, here's the HTTP response code. Here's here's the X, here's the Y, here's the Z, right? Like there are taxonomies. I believe that there is a thing called Elastic Common Schema, which is gaining more and more kind of usage, but it is a little bit heavyweight. So kind of there are trade-offs involved in standardizing on naming schema. but one of the things that OpenTelemetry, which is one of the various instrumentation standards that we use here at Honeycomb, does is that it tries to standardize at least some of those field names.
Thank you. Can you elaborate about the idea to look more into the routing logs when it comes to start as close to the customer first? What important information do Nginx logs capture? Do you have any...
Kelly, you just got very, very soft, I think. Your microphone's a little weird.
Oh, hey. Can you read this question in the chat?
Yeah, I'll read the question. Let's see. Looking into the routing logs. So the question, so the Nginx logs capture, or your service mesh logs capture things like the request URL. It captures which service it is, potentially even metadata like which version. What it does not capture are fields like customer ID or things that are sent in the kind of body of the post request rather than exposed in the kind of metadata of the URL. So I think that you kind of need a mixture both of kind of that top level telemetry that you get from your request logs, as well as having those application specific attributes that you add. So, things like latency automatically captured by Nginx, things like response code automatically captured, but you kind of don't get those application specific metrics and fields. So that's kind of where you have to combine the two approaches.
Gotcha. Can you hear me now, Liz?
No, I cannot. You're still absurdly soft. Let me see if I can fix that on my end. Nope, the problem is not on my end.
Yeah, cool. So I'm going to turn these off, and if we get a bunch of echo, I'm really sorry, everybody. I just want to point you to there's a...
I'll continue reading questions off of the Q&A then while Kelly debugs that issue. Debugging in production, you got to do it. Any rules of thumb on what kind of context on downstream or leaf spans is worth propagating? So I think in general, yeah, that's a super complex question. I love that question. In general, things like the total duration or roll-up of downstream leaf spans is helpful to have. So for instance, we have data on, at least within a single process, how much of the time of a parent span was spent working downstream in the database. So kind of rolling up that data and adding up that data can be really, really helpful. A sufficiently sophisticated query engine should be able to do it kind of without you having to worry about it at the instrumentation layer. Conversely, the fields that get propagated downstream, it's this concept called baggage or correlation context. It's been around both open census and open tracing for a while. I think that you have to be selective with propagating data to child spans because of the fact that it adds additional wire protocol overhead, right? Like if you're sending, 100 extra bytes with every request containing all of your correlation baggage, that can be very, very frustrating. So that's kind of how we think about it. It's a trade-off, but definitely for things where you need to have that available to query on the child spans. But in the long term, a sufficiently sophisticated query engine can kind of do that cross-span correlation, and that's something that we're definitely thinking about and working towards within the Honeycomb product. I do also see a question in the chat. One of the questions in the chat says, am I familiar with New Relic transactions versus Honeycomb tracing? I think the New Relic's synthetics and New Relic's transactions are helpful in some ways, but I think that the ability to issue queries, let me show you, right? Like to issue queries like, hey, I want to understand, how many requests are there that look like this? What's their latency, right? Or even asking questions like, hey, show me what's interesting about these particular things, right? To jump from trace to trace, or to jump from trace to metrics style graph, or to analyze where are anomalies coming from, like what's particularly slow, what's particularly fast, right? Like those are the kinds of things that a product like New Relic cannot currently do. That's not to say they wouldn't do it in the future. It's just kind of that deep top to bottom integration, as opposed to treating kind of, oh, this is our synthetics product, this is our APM product, right? Like, I don't really like the product suite approach. I think that it's a better approach to kind of focus on doing everything in one consistent UI. And being able to explain both, here's what the behavior was for the client, as well as all the way down to the database layer, and be able to go up and down the stack is super, super powerful.
Well, thank you for explaining that. Can you hear me now?
Yes, loud and clear, Kelly. So much better.
Always have a backup microphone. Everyone, I think we got through all the questions in the Q&A. Oh, I saw one more, but just 1 second, because we're right at 10:30. Liz, do you have a couple more minutes?
I do have a few more minutes. I can keep going.
Okay, that sounds good. Everybody, I have this set for half an hour and I have no idea when this webinar is going to cut off. So if we cut off, sorry about that. But let's go for it. How should we handle situations where we need to add instrumentation after the fact? For example, adding child spans under a parent span that didn't previously exist.
Yeah, I think that's really, really great. So you definitely, as you look at a trace, right? Like for instance, if I'm looking at this specific trace here, right, and I see that that this took 460 milliseconds. Let's suppose that these child spans didn't exist here, right? So I just saw 458 milliseconds and I didn't know why, right? Then I would potentially want to add additional instrumentation, right? It doesn't give you, you can't rewrite the past, right? But you can at least add new instrumentation if you catch it being slow again. So that's kind of the guideline is add spans as they're helpful, right? Rather than necessarily over-instrumenting and then paying through the nose.
Fantastic. Okay, I'm going to stop it there because I think you have to get ready for another presentation in the near future. Everyone, thank you so much for interacting with us today. It's so much fun to see you here. If you have more questions, you know where to find us here at team@honeycomb.io. You're already following us on Twitter, but if not, Twitter at honeycombio. What I do want to let you know is you'll get a follow-up email with a link to the on-demand for this, and I'll send a few pieces of content along with it that will be more information about telemetry and SLOs. But I have a favor to ask all of you. We're going to send out a survey. In fact, at the end of this webinar, you might get the link. Could you please fill out that short survey? We want to know if this show works for you. We want to know what went well, what didn't go well, and what other topics you think are interesting. So if you have 5 minutes to fill that out, that would be fantastic. Liz Fong Jones, thank you so much. It was really nice talking with you today.
Cheers.
Yep. We'll see you all in the future. Bye.